Right. You are welcome back to Sir Lisbon tutorial platform. And we are taking the course Ordinary Differential Equations. Ordinary Differential Equations. So, we will first consider the fundamental concepts of differential equations. That is the topic that we are looking at in this video. But we will limit ourselves to the first subtopic, that is the introduction to differential equations. Introduction to differential equations. Differential equations were first used in the early 18th century to solve problems in mechanics. But more recently, the theory of differential equations has found its way into social and life sciences. For example, differential equations are applied in the field of biology, chemistry, physics, economics, engineering, history, banking, and so on. Many physical, chemical, and biological systems can be described using mathematical models. Once the model is formulated, we usually need to solve a differential equation in order to predict and quantify the features of the system being modeled. The world we live in is of interrelated changes entity. Now, the position of a moving body or a moving object changes with time. And also the bending of a beam changes with the load placed on it, and many more. In the field of mathematics, these changing entities are called variables, which can be linked together. A linkage or a relation in which one variable, say y, depends according to a certain law on another variable, say x, defines a function. So this is the definition for a function. We are saying that a linkage or a relation in which a variable, say y, depends according to a certain law on another variable, say x. We are saying that such a linkage or such a relation is termed as a function. The first quantity y being a function of the second quantity x. We write y equals f of s for this particular relation. The variable s is called the independent variable, whilst the variable y is called the dependent variable. The rate of change of the dependent variable y with respect to the independent variable s is called the derivative of the function, and it is denoted by y prime or dy over dx. The variables and the function together with its derivative can also be linked together by an equation, and such equations are called differential equations. Differential equations. An equation containing the derivative of one or more unknown functions, that is the dependent variables, with respect to one or more independent variable, is said to be a differential equation. So this is the exact definition for a differential equation. We are saying that an equation containing the derivative of one or more unknown function, that is the dependent variable, with respect to one or more independent variable, which is the known function, is termed as differential equations. In other words, a differential equation is an equation involving the unknown function y equals f of s together with its derivatives. Together with its derivative, either y prime prime, or y to the power n. But take note, the n in the bracket is the order of the derivative. It is not the degree, but rather the order of the derivative. Mathematically, a differential equation may be written as f of sy y prime up to y to the power n equal to 0. So I said earlier that the n in the bracket is the order of the derivative. This is an implicit way of expressing differential equations. Now the explicit way of expressing differential equation is written as y to the power n equal to f of sy y prime up to y to the power n minus 1. So this gives us the explicit general form of differential equation. Following are some few examples of differential equations. So let's take a look at these examples. Y prime plus sy equals x squared is an example of differential equation. It's an example of differential equation. We also have y prime all to the power 5 equal to cos s. We have y prime plus 5y prime plus y equals 0. We also have the square v over the x squared plus the square v over the y squared plus the square v over the z squared equal to 0. This is a different concept altogether. This is a different concept altogether. And this is an example of a partial differential equation. This is a partial differential equation. So this course is only limited to ordinary differential equations. When you get to partial differential equation, you get to know more about this example. We also have d cube y over dx cube plus 3 times d squared y over dx squared plus y equals e to the power x. We also have the u over the x plus sy the u over the y equal to sine sy. So this is another example of partial differential equations. As I said earlier, we are looking at ordinary differential equations under this course. Now let's take a look at some applications of differential equations. The most familiar example in the field of application is the Newton's law. The Newton's law. This equation, we have been using this equation in physics. F equals ma. That is, the force acting on the body is equal to the mass of the body times the acceleration moved by the body. So this was derived from Newton's second law of motion. So you can go and read more about that. Now, if a function u of t is the position at time t of a mass m acted on by a force F, then we obtain the equation below. That is m times d squared u over dt squared equal to f of tu du dt. So f is a function of t and u together with its derivative, that is du dt. So equation 9 is an example of differential equation. So we will end our lesson here. And we will continue in the next video. Don't forget to subscribe to the channel. In the next lesson, you will be taking a look at classification of differential equations. So kindly subscribe to the channel and be updated with the subsequent videos. Bye bye.